Hi guys, I'm going to make quick videos. I'm going to talk pretty fast, so pause it if you need to. Just kind of summarizing what we need to do for each one. We're going to read through nicotine patches are often used to help smokers quit. Does giving medicine to fight depression also help? A randomized double-blind experiment assigned 244 smokers to receive nicotine patches and another 245 to receive both patch and antidepressant. Right away I'm going to highlight, okay, here is my N1, here is my N2. If you keep reading, it says 40 of the subjects in the nicotine patch group. That's my X1. Excuse me, had abstained from smoking. And 87, that's my X2. Had abstained with the patch plus the drug. It says construct and interpret a 99% confidence interval for the difference in the proportion of smokers. Okay, so let's go through the state real quick. State, I'm just reading and I'm saying, okay, how did I outline it when I was looking at my numbers here? So N1 is my first group that I identified. It doesn't matter how you identify it, P1 versus P2, as long as the conclusion, everything matches up. So why did I do P1, the true proportion of smokers like these who quit with the patch? That's the first one I read. 244 are the ones with the patches. That's the first group they described. So I identified that as P1. And then the second group that they described were the ones with the patch and the drug. And so that's why I defined P2 as the second one. Again, if you flip-flopped it, that's okay, and I'll talk about where that's going to change. The next part is the plan, and I put the method first. It's a 2 sample Z interval for P1 minus P2. Random, the treatments are both given randomly. So this is an experiment, and so it's going to change a little bit compared to what we normally have. If it's not an experiment, you would say they're both random samples. The independence is typically the 10% rule for both of them. And then also that each individual, or the groups, excuse me, are independent of each other. So you have those 3 arrows. For this one though, since it's an experiment, we have to, even though it's an interval, we have to use what we talked about on Thursday of last week in the 10.1C notes. When you're dealing with an experiment where there's volunteers, you have to say because the treatments are given randomly, the groups are independent of each other. And then you also have to state individual responses are independent of each other. Okay, I'm talking fast, so again, like I said, this is just supposed to be quick. Here's how you do it. Make sure you rewind, pause if you need to, and then write down any questions that you might have. The next one is the normal condition, and the normal condition is where you're going to take your p hats. So my first p hat is x1 over n1, so that's 40 over 245, I believe. Let me double check. Oh, I lied. X1 over n1, so x1 is here 40 over 244. This is my n times p, so I'm taking 244 times 40 over 244 is greater than or equal to 10, and I'm doing it again with 1 minus. And now I have to do it with my other population. I'm going to just quick grab my sheet so I don't have to keep scrolling up and down and going, it's already done. And my x2 then is going to be 87 over 245. So there's my p hat. And I'm getting a little scrunched here. I don't like that. I'm sorry. And then 245 times 1 minus 87 over 245 is greater than or equal to 10. All right. Our conditions are done. Our method is complete. And now we're going to move on to the do part. I'm going to set it up how I have it. So I'm going to do p hat of 1 minus p hat of 2. That's my statistic. I'm interested in the difference. So right away, I'm going to see 40 over 244 minus 87 over 245. Now I need my plus or minus my critical value. My critical value for 99% is 2.576. At this point, if you don't know how to find that, you need to come see me right away. And then times my standard deviation, and you can find this on the formula sheet. Again, if you don't know how to find this on the formula sheet, that's your job at home today. Make sure you know where this formula is on the formula sheet. And if you don't ask, shoot me an email, I'll show you where to find it. So I'm going to take my first sample, 40 over 244, times 1 minus 40 over 244. all over 244 plus 87 over 244. Oh, excuse me, 245 times 1 minus 87 over 245 divided by 245. Now, please don't try to calculate this all on your calculator. Go to your grapher. Go to stats. Go over to tests. Please do not do a two sample. You're doing a two proportion Z interval. So you're going to scroll down. There we go. Hit enter. And I already have it all set up with my X1. I do not. I lied. I have it for another one. So I'm going to type in my X1. My X1 is 40. My N1 is 244. My X2 is 87. My N2 is 245. And I'm calculating a 99% confidence interval. And there we go. I can bring this screen over. And now all I need to do is write down that interval. And I'm going to interpret right now to conclude. I'm 95% confidence that the interval from negative 0.2908 to negative 0.0915. Now, how you set up your P1 and your P2, it might be positive numbers that you see. So you put from 0.0915 to 0.2908. I did the patch one first, minus the patch and drug. So I did mine different. I'm 95% confident that the interval from negative 0.2908 to negative 0.0915 contains the true difference in proportion who abstain when using only a patch and smokers who abstain when using the drug and patch. Okay, any kind of follow-up questions you might see would be, do you have evidence that there's a difference? We do have evidence there's a difference because 0 is not contained in this interval. If 0 is contained in this interval, we don't have any evidence for a difference because there is a chance that 0 would be the true difference, okay? And if the true difference is 0, that means that the two populations are the same. All right, I'm going to sign off on the interval. Thanks for listening, and let me know if you have any questions.